Next example I want to look at is interpreting the graph of f. Given the graph of f, we want to answer some questions about f prime, the first derivative, and f double prime, the second derivative. Okay, first working with the first derivative. First derivative from f, we're going to simply be looking at slopes of the tangent. So are we increasing or are we decreasing? As we come in from negative infinity, looks like from negative infinity to negative 1, our first derivative is negative. And again, the slopes again look negative from 0 to 1. So again, if I follow it from 0 to 1, all the slopes there look negative. Next, let's look for where they're positive. When are we increasing? Going up from left to right. Slopes of the tangents are positive. We're positive from negative 1 to 0. And then we're positive again from 1 to infinity. Where's f prime 0? In this type of graph, this would occur when the slopes of the tangent are horizontal. So this occurs at 3 different points at x equals negative 1, at x equals 0, and at x equals positive 1. Next, moving on to the second derivative. Second derivative answers questions about inflection points and concavity. So looking at this graph, f prime, f double prime would be positive when we're concave up. Looking at this graph, looks like we are concave up from negative infinity to negative 1/2, and that's approximate. And then again, it looks like we're concave up from positive 1/2 to infinity. Just again, outlining these points here, concave up, and here, concave up, until we get to about that half. Second derivative is negative when we are concave down. Concave down, the only interval looks like we're from 1/2, negative 1/2 that is, to positive 1/2. When the second derivative is 0, it means we have an inflection point. So there has to be a change in concavity. So we have one change in concavity at x equals negative 1/2, and then another change in concavity at positive 1/2.